Thank you so much, Piero, for having me. It's so nice to be here at Stanford. I'm your neighbor down the street, so thanks for having me up. I changed the title of my lecture, which was 3D Printing the Future, into 3D Printing with Atmospheric and Geologic Materials. So out of the lab and into the landscape. And this kind of happened during COVID for me, where we all learned about the campuses closing, and we had to leave and go home and be alone. And the first thing I thought was, oh no, what am I going to do? Like, all my robots and 3D printers are in my lab. So I put them in the back of my car and drove them home and set them up in my backyard. And I just started 3D printing in the backyard. And then I started 3D printing in the desert. And now I've been 3D printing in Italy and Greenland, and I'm never going back into the lab. So it's been a kind of amazing experiment, and I've learned a lot of new things through this kind of transformative timeline. And so I want to start by talking about atmospheric architectures, and as Piero said, I'm an architect, and I want to talk about 3D printed architecture as in buildings, which is, of course, the way we conventionally defined architecture, but also think about architecture as something that defines designs or systems that are complex and carefully crafted, so software, for example, or objects. And I'll start by talking about ash. So something that, of course, we're all familiar with here in the Bay Area. We have experienced a number of wildfires over the last 10 years. I think 13 of the last 20 wildfires have been the most devastating in the history of California. In the last 10 years, over 3,000 structures or buildings have been destroyed because of these wildfires. And it made me wonder, is it possible to take this material, the ash, that is a byproduct of the wildfires, and 3D print with it? And I started to question, is it possible to think about how we build the future constructively using a material that is a product of destruction? And so I started collecting the wildfire ash on my street in Oakland. All of the ash was blowing, of course, up from Santa Clara County, from the SCU and the CZU lightning complex fires in 2020. And it was landing on all of the cars and the windowsills along my street. And so I was collecting this ash, and I worked with a polymer scientist to develop a filament for 3D printing in a desktop printer. So you can see here this very standard, very inexpensive, kind of off-the-shelf Prusa printer, which uses 1.75 millimeter filament, which is a plastic material quite typically. And I'm printing the ash filament into these vessels that I call WUI-ware. So the WUI is the wildland-urban interface, and this is the zone where most of the wildfires are the most destructive. And so these are WUI and ware, because I'm making kind of tableware out of the 3D printed wildfire ash. And for me, this raises questions about how we rebuild from the ashes. Can we quite literally use the ashes to build the future and to replace the buildings and the objects and the structures that we have lost? And what artifacts can help us remember that we have lost? So many people have lost everything in these wildfires, and how do we memorialize what has been lost? And how do we create something new out of something that is destructive? Snow. This is another atmospheric material that I've been working with over the course of the past year. I had the chance to go to Ilulissat, Greenland, in January and February. It's very dark, very cold, but we can talk about that later. Ilulissat is a very special place. It's right next to the Ilulissat ice fjord, which you can see here. This is a glacier that calves 10% of the world's icebergs. So it is the most productive glacier in the world. And I decided to visit the town and create a snow-catching building there. It's a building that I call, and this is just a photograph of the village, which sits on what is mostly granite bedrock with some lichen, moss, a few wildflowers. That's it, no trees. But you can see this very charming, colorful village and the ice fjord and the icebergs in the background. And I decided to build a building, a kind of prototype, a small building that would catch snow, as a way of kind of measuring or thinking about how climate change has so drastically affected this part of the world. You can perceive the change in Greenland and Iceland to a much greater extent than how we experience it here. So for example, the edge of the glacier has retreated 125 meters in just 1 year. And there are considerably fewer icebergs floating out into the harbor this year than there were last year, for example. And because a lot of the work that I do is 3D printed, I originally wanted to 3D print this building. And when I went there, I realized, oh, there's no way I'm going to be able to 3D print this building unless I bring all of my 3D printers and I bring all of the materials, because there is really very little or nothing to 3D print with here. So instead of 3D printing the building, I decided to think of the building as a 3D printer itself. So one of the first types of 3D printing that was invented in the early 80s is called binder jet printing. And this is where a powder is deposited on a build plate, and then you jet a liquid onto that powder to solidify it. And I thought, well, we have a powder falling from the sky, right? The world is a 3D printer. And what if I make a building that acts like a 3D printer instead of 3D printing the building? And I would just need to create these shelves, these little build beds, that would catch the powder and organize it in the form that I wanted it to create. And I did some studies here in Colorado to test the resolution of that idea. So here you can see this is actually a 3D printed 3 foot by 3 foot mock-up. The snowflake motif that emerges when the snow falls on the build plates. In this image, the prototype is standing perpendicular to the ground, kind of 90 degrees, like a wall would be. In this image, that same prototype is tilted back about 45 degrees, the angle of a roof. And you can see the difference, interestingly, something that I did not anticipate and I could not have modeled in the computer. So here the white creates the image, and then the black creates the image of the snowflake. I made a proposal for this building in Greenland using the snowflake motif because I thought, wouldn't it be lovely if the building was like a Nordic sweater and it looked, warm and cozy. But they suggested that I actually look at their local craft traditions instead. So there is a history of an embroidery technique in Greenland called evitet, which uses seal skin. So it's a very fine cuts of sealskin along the edges of the skin, and it's used to decorate the clothing, the traditional clothing that the Greenlanders wear. And you can see an example of that here in the boots. And this is very much a gendered craft. Only women embroider with the sealskin. And so I applied the evitet embroidery to the surface of the building, so that when it snowed, this embroidery, this kind of feminine pattern or craft tradition would appear at the scale of the architecture. And you can see that here on the surface of the building without snow. I wanted to use traditional building materials. As I mentioned, there's not a lot there to work with. There's snow, there's turf, and there's wood. So the Greenlanders have been building with wood for about 800 years, driftwood or wood that's been imported from Scandinavia or Canada. And so it made sense to me to build the structure out of the local wood that was available. And I kind of value engineered the design to use all of the wooden lumber that was available in in the Home Depot of Greenland, so that I would not have to import any additional materials. It has a window. You can go inside the building and stand and look out at the icebergs as they move across the landscape. And I've been thinking about how this structure can be a barometer to measure falling snow and wind over the course of the year in a way that is maybe not exclusively scientific or data-driven, the way that I think most people are looking at climate change and snowfall in Greenland, but one that is more visual, one that you can occupy. Here you can see this is a very recent photograph from this past month, so the kind of snowfall that's taking place here in the spring. So I also want to talk about 3D printing geologic architectures using materials like salt, clay, and soil. So salt is a material that's very local and native to us here in the San Francisco Bay Area. Salt has been harvested from the Bay Area for over 150 years. Now, 150,000 tons of salt are harvested every October and November. It is actually a kind of farming process. So the water comes into the bay, it moves into the crystallizers, and of course it only takes sun and wind to evaporate that water to create the salt fields that you see here in the South Bay. Here's an example. This is myself and Ron. We had the good fortune to go out to the crystallizer fields in Milpitas a few years ago. And this is the harvest at the beginning, just to give you a sense of how much salt we are creating here in the Bay Area. And you can binder jet with salt and make functional objects such as these 3D printed salt shakers, which are solid on the exterior, and the salt is left loose on the interior, so you can shake it out and season your food. One of the things that I like most about 3D printing with salt is the inherent optical qualities that you can find in the material. It's always translucent. It doesn't matter how thick or thin you print with it, light passes through it. And we experimented with different ways of stacking our 3D printed salt parts to make larger assemblies and structures, and the creation of forms that could be made any other way, but only through additive manufacturing. The company that owns all of the crystallizers in the South Bay has given much of it back to be restored for wetland restoration, but they also set aside around 10,000 acres to create housing for around 30,000 people in the Bay Area, which made us wonder, could this material, literally ground beneath your feet, be used in the creation of these homes that they were proposing to build? So we wondered if we could create salt igloos, or kind of salt igloo, through the 3D printing process. And we were inspired by these very beautiful traditional forms, kind of boiling tanks with the salt crystals in the baskets used for extraction, and developed a salt crystal or building tile inspired by the geometry of the salt structure itself, and then radially arrayed around 300 of those 3D printed salt tiles to create this tent-like structure, which you can see here. So all of these tiles are unique. They're alphanumerically coded, and they go together perfectly to create this structure, which you can see here, the interior of. And again, you can see the light passing through not only the openings or the apertures in the salt, but through the salt itself to create this soft, diffuse lighting condition in the interior. And this is what it looks like from the exterior. Clay. This is another material that we've been 3D printing with for about, I think, 9 years now. We developed a process for 3D printing which we call G-code clay. So instead of 3D modeling our designs in the computer, we decided to start just designing with the G code itself. So G code is the language that speaks to all 3D printers. So we literally just take a line of clay for a walk, and sometimes this line of clay has glitches and errors and loops and waves, and these loops and waves make our 3D printed pieces stronger. It also makes them more textured. For myself, it gives them, a kind of woven or knit-like quality, so it looks like something soft when it's really something quite hard. And there are glitches and errors that happen that you can't anticipate in the digital world. They only occur in the physical world. So here, for example, this clay body is very stiff. Maybe it was a hot, dry day. So when we make the loop with the clay, it was breaking. And it's these moments that are very exciting to me. So we developed a software that runs in the cloud. It's called Potterware, and it really lowers the bar so that anyone can learn how to 3D print. You don't have to have any experience 3D modeling, and you don't have to have 3D printed anything before. I can teach all of your children, your 8th graders, to 3D print using this software. So it's a kind of vessel form, and then you can control the texture on the surface, you can control the profile of the vessel, you can control the number of repetitions that you're creating just by moving these sliders. And when you finish with your design, you select the Export G-code button, and it's ready to 3D print. So you can very quickly make quite a variety of unique designs. And then you can start to bring in different materials that might be important to you. This is a cookie jar. It's called the Fratello biscotti jar. My grandfather immigrated here from San Fratello, Sicily. And so I flew to San Fratello because I had this feeling that there was clay there, and there was. And so I was digging this clay out of a valley in between some mountains and created this vessel because I remember going home every Christmas to my grandparents' house, and they always had cookies. And the taste of those cookies and the smell of those cookies and the cookie jar by extension feels like love to me. And so the software, the hardware, the material, and the memories all come together in this particular object. And I'm currently working on another project where I'm 3D printing bricks out of local clays and firing them to different temperatures to create an interior installation, which will be complete this August. And we've continued to explore this logic that we developed in 3D printing clay with 3D printed soil. So we're actually digging here again, the ground beneath our feet, using local soil, mixing it with water and chopped straw in order to create buildings using robotics. This is a project called the Casa Covida, which is a 3D printed adobe project. It's a building that has 3 rooms. We call it the Casa Covida because it's a house that was built during the time of COVID, but it's also kind of a play on words. In Spanish, this is a house of cohabitation for 2 people to quarantine in. So here I'll just show some videos that describe the process of using this very lightweight mobile robotic arm to extrude the adobe. And it is the same formula that's used to make adobe bricks. We haven't changed anything. It works perfectly in the 3D printer. And we put the robot on this horizontal rail so we can print multiple circles at one time. So we are using the landscape as our lab, and we really rely on the sun and the wind to harden or stiffen the adobe. We can print about 18 inches at a time, and then we move to the next circle, and then the next one. And by the time we're finished, we can build on top of what we already printed. So here's just a video that shows that process of extruding the clay. All of the walls are a double layer There are two sine waves that kind of touch or kiss in alternating waves, and this gives the wall strength. There are 3 different spaces: a room for sleeping, a room for eating, and a room for bathing. We also put the robot arm up on a box so that we could print higher, because we can control the robot with our smartphone. So this is my partner, Ron, holding his phone, driving the robot. We printed over lintels to create doors and windows and openings. And this is the entrance to the room for cooking. So you enter here, there's a 3D printed hearth, and we created all of the cookware as well out of local micaceous clay from northern New Mexico. So we have a bean pot, a tagine, and a bread basket. There's a room for sleeping with a view to the mountains beyond. The bed is covered with local sheepskin, and these beautiful textiles are woven by a friend of ours who's an indigenous weaver. And we used the wool from local sheep. And if you look closely, you might recognize that the motif on the pillows is actually the floor plan of the building itself. And this is the room for bathing, which uses one of the metal tanks that the ranchers use to give their cattle water. It's surrounded by river rocks, and it's a wonderful place to lay in the water and be connected both to the ground and the sky. So for me, this is a kind of new paradigm, a new way of thinking about how we use traditional materials and emerging technologies to build the future. Thank you.